The PEG radio system as a concept is rather a unique take on traditional radio systems. Utilizing unconventional store and forward or Storeford technologies, custom innovative equipment, and unique network designs to empower the organized emergency preparedness team to take their communications to the next level. An out-of-the-box approach to every aspect of the system offers new ways of doing more with less. This presentation will focus on a few topics: the PEG radio system overview, the progress report, phases of implementation, and recommendations. The use of store and forward or Storeford repeater technologies has existed since the early 1990s and was used mostly in ham radio as a novel, inexpensive but effective alternative to conventional duplex repeaters. This technology was rarely embraced outside the ham community due mostly to a few inherent operating traits that were considered too awkward for general radio users. In 1996, U.S. Preparatory's founder recognized the incredible potential in this technology and began to work on solutions to resolve these inherent traits. The solution was to rethink every aspect of the Storeford repeater system, starting with the design and manufacturing of new repeater controllers and ending with a new approach to system layouts, radio protocols, and programming. The Preparatory Emergency Groups or PEG radio network combines enhanced Storeford technologies and real-time simplex communications, offering a well-balanced combination of capabilities, efficiencies, and cost-effectiveness that's simply not possible with a conventional radio network. The basics behind a Storeford repeater system is very simple. When a field radio transmits a message, it's received by the Storeford repeater and is stored digitally within the controller. When the field radios stop transmitting, the repeater forwards the message out to all field units. The delay experienced is equal to the message itself. In this case, a 15-second message results in a 15-second delay before field radios begin to receive the message. One obvious characteristic is the transmitting radio will receive itself. This ensures 100% confirmation that the message was decipherable by others and allows for local coverage checks to be done by a single user. A Storeford repeater is the only radio system that returns radio traffic back to its source. The benefits of this simple concept, when combined with the new controller design, offers a dramatic increase in capabilities and functionality not seen in any radio system. The system consists of many first-of-its-kind unique product and ideas that are being developed and tested. Here are the latest developments. The heart of the PEG radio system is the SMC200 Storeford repeater master controller and its remote node counterpart, the RNC200. Some of the features include proprietary Q-tone activity alert system, which virtually eliminates transmitter collisions very common on a store and forward system. The unique NetLink port allows 3 methods of linking outside radio networks or local radio systems into the primary network: off-grid friendly low-power consumption and on-air battery condition statuses, more than 50 programmable features, an onboard tone paging USB interface, and remote switchable outputs to control outboard hardware. The CSA coaxial skirt antenna is an extremely robust, single-frequency antenna designed for remote node stations and built to last. Designed for low maintenance and reliability in hard-to-access sites, with no delicate parts, make this antenna ideal for off-grid tree mounts. It's made out of stainless steel and aluminum and is cut to length specifically to the frequency specified with no adjustability. Website features new package kits designed for easy purchasing of the necessities for your vehicle, home, and infrastructure. Only compatible options will be shown, avoiding incompatible purchase choices. Just choose your personal tastes in antenna, mounts, and color. Kits will include all that's needed for installation. The HL1 remote head kits for the Motorola MaxTrack and Radius. This kit allows for much easier mounting in today's tight vehicles. Mounts the control head of the radio separately from the transceiver. The control head can be screw mounted with the included bracket or mounted with double stick tape or Velcro. Remote cable lengths are available in 2, 6, 10, and 25-foot lengths. The XTR extender system rewrites the performance level on any portable radio. The XTR unit connects to the existing mobile or base radio. It allows an otherwise incompatible UHF portable radio to be compatible with a VHF low-band radio system. It bidirectionally extends the mobile base radio capabilities to your UHF portable, and it makes your UHF portable radio as powerful and as efficient as your mobile or base low-band radio. Unlimited amount of in-range portable radios can use a single XTR system. The FSC3 is a fixed station console with a multi-role modular design. It can be configured in one of three ways. As a home base station, it'll include a single low-band radio, power supply, battery backup charging system, 2 USB charge ports, a 12-volt accessory socket, map light, and optional XTR system. As a repeater station, it'll contain a single radio with a power supply and an SMC 200 controller. As a remote node station, it contains 2 radios, a power supply, and an RNC 200 controller. Auto switching over from DC when AC fails, and solar panel charge capable. Due to the multiple task levels of the project, it's been divided into several phases. This helps ensure that all prerequisites are met prior to moving on to the next phase of the project. Phase 1. Choose the proposed locations of the main repeater and/or remote node sites. Prepare the system for testing by answering a few questions. How many zones will your system contain? What is the approximate location of each fixed station in the system, including town or city, GPS coordinates, and/or street address if applicable? Will your system contain base only, vehicle portable only, or both? The FCC Frequency Coordinator will provide a list of candidate frequencies that U.S. Preparatory will assign for use as test frequencies. Radio equipment will be programmed with the candidate frequencies as zone and local channels. Phase 2 will be mobile and base station equipment selection, purchase, and installation. On the left side is a Motorola Radius with an HL1 remote head kit installed in a Toyota pickup truck. On the right side is the Motorola Radius custom installed in a Subaru Baja without a remote head kit. These are the antenna systems installed in both vehicles. Also on Phase 2 is the home base station or HBS equipment selection, purchase, and installation. On the left side is a custom installation of 2 Motorola CDM1250s. Installed in a remote head configuration, the transceivers for both radios are installed in a box on the foundation wall in the basement, just below this location. On the right side is a basic installation of a Motorola Radius. You'll see in this installation that there are no consoles, nor is it a remote head kit mount. It's simply mounted underneath the cabinet. The power supply for the whole system is actually on the refrigerator just next to it, and this particular one has one of the prototypes of the XTR system mounted on the right side. And here are the antennas for both installations. Phase 3 is obtaining an equipment test kit for your proposed radio system. The test kits will help you assess the best locations to install your infrastructure. Available in Category 1, 2, or 3 systems. Includes all that's necessary to test each segment of the system. Category 3 systems will contain 2 parts, a Storeford repeater kit and a remote node kit. All equipment will be programmed with frequencies suggested by the FCC Frequency Coordinator. Nearly all the equipment within the test kit will be rolled into the final permanent system. Phase 4. Test proposed repeater and remote node locations for link confirmation and talking. Testing is vital to find infrastructure locations that will work for your coverage needs. Configure your test sites as close to the final configuration as possible, including height, antenna feed line, and antennas. Plot locations of infrastructure on the map. Confirm link activity between remote node sites and repeater. Plot coverage of a field radio talk-in on the map. Ensure adequate overlap between zones for total coverage. Phase 5. Apply for the FCC PEG radio license. This PEG radio license is a complete departure from FRS, ham, GMRS, or other public systems. There are no exams to study for or license grade levels. Licensee or group owns all of the equipment on the network. The licensee has priority exclusive use of the frequencies within 75 miles of the coverage area. A single license covers over 100 authorized users for this private radio network. Personal unit IDs Radio protocols and procedures are set by the group, not by a community of outsiders. A unique shopping cart-like experience on the U.S. Preparatory website offers a familiar method to creating your new PEG radio license. Phase 6. Installation of remote nodes and repeater equipment at confirmed permanent locations. Install and weatherproof all infrastructure equipment at each fixed site. Confirm proper operation of each site and equipment. Maintain each site for equipment efficiency and safe access. U.S. Preparatory recommends the following to proceed. Begin to plot out the infrastructure locations first. Then, submit the locations of each proposed site to U.S. Preparatory for a list of candidate frequencies from the FCC coordinator. Purchase the mobiles and base radio equipment. U.S. Preparatory will program all equipment to the frequencies recommended by the FCC frequency coordinator prior to delivery and installation of the equipment. Test your sites and field radios with the available test kits. Apply for your FCC radio license on the U.S. Preparatory website. And finally, permanently install your radio infrastructure. For a more detailed view of this enhanced Storeford repeater system, visit the Documentation's video page on the U.S. Preparatory website.